let's talk about why Lasso reduces some of the coefficients to exactly 0. This works if you look at the ridge and Lasso cost function in a different way. The ordinary least square estimation can be thought of as an unconstrained optimization exercise. If you think of ridge and Lasso, they are in some way putting a constraint on the unconstrained optimization exercise. Now, in the original form of ridge and Lasso, you cannot see that constraint. If you modify the ridge and Lasso cost functions, you can very much see the underlying constraints. Now, if you see the underlying constraints, it can be said that constraint which is enforcing a kind of like a feasible set on the features or the betas or the coefficients. So kind of like a budget set of economics. If you have read something about economics and budget sets, this would seem familiar to you. You're trying to optimize something based on a budget, and when you have some of the squares of features, there what happens is that the budget sets are kind of like smooth in nature. But when you're trying to make a budget function which has some of the absolutes of the features, there will be sharp turnings, and that sharp turnings, rather the kink in that budget set, could give you a possibility that you intersect at a point of that budget set which forces few of the features to get to 0. Now, this is something which you can very much understand if you remember what a mod function look like and how a circle looks like, and then you think of a multi-dimensional world, and then that would make more sense to you. So this is the gist is the Lasso has sharp boundaries of constraint optimization, and ridge has smooth boundaries of constraint optimization. And what is the unconstrained optimization here which we are referring to? The ordinary least square estimation. So when you put a constraint, you get ridge and Lasso, and the Lasso constraint reduces few coefficients to exactly 0 sometimes.